Good morning, class. This is Mr. Eggleston, and this is lesson 8.5 for Algebra 1, working with exponential functions. In this lesson, you will learn how to, given values of a geometric sequence or exponential function, how to solve for the common ratio, what we're multiplying by each time. We'll also learn how to find missing values of a geometric sequence or exponential function, and also how to construct exponential functions from a description, table, or graph. So let's begin this adventure by starting with this activity. How much acetaminophen is left? Acetaminophen is a pain-relieving drug found in medications like Tylenol. Acetaminophen enters the bloodstream and over time is absorbed by the tissues. Here's the info. A patient receives a 400 milligram dose, okay? And after 4 hours, only 164 milligrams of the drug remain in the bloodstream, okay? If acetaminophen is absorbed by the body at a constant rate, how many milligrams are absorbed per hour? Well, if it's at a constant rate, it means it's arithmetic, which means it's linear. So we would basically say we would go 164, or actually, we have 400 initially, and then minus 164 over 4 hours. So it decreased from 400 to 164 over a time period of 4 hours. And when you calculate that, that works out to be 59 milligrams per hour. Okay? Now, if acetaminophen is absorbed at a constant rate, i.e. at the rate given above, how many milligrams would be in the patient's bloodstream after 3 hours? Well, you would take the initial amount, 400, and subtract out it's 3 hours times the rate of 59 milligrams per hour. And that would work out to be 223 milligrams. Okay? This is linear. All right? Constant rate means it's linear. This is a line. Equation of a line right there. You could say the amount of acetaminophen absorbed, I guess I'll call it the absorption rate, A, as a function of time, T, would be 400 minus 59 times t. And that's just an equation of a line where the slope is 59 and the y-intercept at t equals 0 is 400. So that's an equation of a line. However, on question 3, in reality, the acetaminophen is not absorbed at a constant rate. Instead, a certain percent of the acetaminophen is absorbed every hour. How is this different? Well, instead, I gotta blow this up so I can write. So I gotta make it a little bit smaller. Okay. So instead of the drug, I just don't want to write acetaminophen. Instead of the drug going down by the same number, going down by the same amount, each hour, by the same amount each hour, it goes down down by the same factor, by the same percent or factor. In other words, we're multiplying the amount we have by a number, okay? This means less is absorbed each hour because the amount of acetaminophen in your bloodstream as the hours go by is less. So if it's a constant factor, a constant percentage of that number, as that number goes down, the amount absorbed goes down, okay? Since it seems like absorbed that, okay. Okay, while it's instead a certain percent, that's the key, a certain percent of the acetaminophen. That means it's exponential. This is going to be an exponential function. Because we're multiplying by the same number each time. So how do we figure this out? Well, here it comes. We go through these steps. While it is helpful to think about the percent of the drug that is absorbed, it is more common for medical professionals to think about the quantity that remains in the bloodstream. What proportion of the initial amount remains in the bloodstream after 4 hours? Well, after 4 hours, they say, let's see, after 4 hours, there's 164 milligrams of the drug. So that would be 164 divided by the original amount, 400. All right, and if you use your calculator, that equals 0.41. So part B is a little bit trickier because they want to know what percent of the drug remains in the bloodstream each hour. Okay, so think about this. The way this works is they want to know what R is, where R is the rate, the absorption rate. So we start with the 400. That's our original amount. Now after 4 hours, that means we multiply by this R 4 times. 1, 2, 3, 4. And if we do that, the amount left was the 164. Okay, right? It said 100, I can't even talk. It says 164 milligrams. And so that's the basic idea. So it'll be, so that would be R to the fourth equals 164 divided by 400, which was the 0.41 that we had calculated. So notice this is a power function, right? R to the fourth equals 0.41. To solve that, we would have to take the fourth root, because remember, what's the inverse of raising a number to the fourth power is taking the root. So it'll be the fourth root of both sides. Okay? So that's the fourth root of 0.41. Okay? So I got to spread this out a little bit. Okay. There we go. So now, using my calculator for the fourth root, and I'll show you this in class, how to do this, is we're going to go boom. Oh, I see. Okay. We will go fourth, boom, of 0.41. That gives me, 0.800. It's just 0.8. I mean, 0.8002. So, and it goes on even past that. So I would say it's about 0.8. So so about 0.8 remains in the bloodstream each hour. Okay? Now, knowing that, how can we use this? Well, we can go 400 after the first hour. We multiply by 0.8. So that would give us 320. 400 times 0.8 is 320. Then we multiply by 0.8 again. And the second hour would be 320 times 0.8, which is 256. We multiply by 0.8 again. Each hour, we multiply by 0.8. And that will give us 204.8. All right. And finally, the last time would be 204.8 times 0.8 gives us 163.84. So do the values in your table agree with the initial information given? If not, where do you think you need to revise your thinking? It pretty much does. I mean, they said after 4 hours you should have, if you go back up here, it said after 4 hours, 164 milligrams of the drug. I'm looking right here. Right after 4 hours, 164 milligrams. And our model gives us 163.84. That's a pretty close approximation, right? We would normally round up to 164. So, yes, they do. Okay. What percent of acetaminophen remains in the bloodstream Looks like something, what percent of acetaminophen remains in the bloodstream each hour? What percent of acetaminophen is absorbed? So for whatever reason, this got cut off. So what percent remains in the bloodstream? So if you look at this, you would see that 80% remains because we're multiplying by 0.8. for the milligrams remaining. So 80% remains. And then 100 or 1 minus 0.8 is 20. 20% gets absorbed. Okay? So what that means is that there is a decay rate. Absorption rate. They also call it decay rate of 20%. Okay? So here we go. Consecutive terms of a geometric sequence or exponential function change by a constant factor, r. Okay? You're multiplying by that. Multiply by r to find next term. We showed you how. Divide by r to find prior terms. To find the value of r, write an equation, which is exactly what I did, relating the two given terms. And what you do is how many times did we multiply by r? You know, like here it's the second term was 4, and then the third, fourth, fifth, sixth, after the seventh term is 120. So we solve this equation, which would be 4r to the fifth power, because there's 1, 2, 3, 4, 5 r's, equals 120 divided by 4. You get r to the fifth equals 120 divided by 4. 120 divided by 4 is 30, so r to the fifth is 30. R equals 30 to the 1/5 power. And then you would use your calculator to get the ugly decimal. I hope that made sense. You have a great day.